Okay, guys, so expect these types of questions to be on the Quiz Friday. Check it out. It tells you f of x is negative 3x squared plus 2x to the third minus 1. State the leading coefficient. The leading coefficient is not negative 3. I trick you. What is the leading coefficient? It's actually 2. That's the leading coefficient. Why? Because it's not in order. You have to first rewrite it in standard form. You got to go with the highest exponent first. So that's a positive 2x to the third minus 3x squared minus 1 at the very end. And now you can see that your leading coefficient is 2. Now state the degree. Well, the degree is easy. What's a degree? 3. Piece of cake. The highest exponent on your function. Number 3, state the constant. What's a constant? Negative 1. It's the number without a variable at the very end of a standard form function. Number 4, classify f of x first and last name. Well, the first name is based on the degree, the highest exponent, which is 3. So what's the first name? Cubic. And how many terms are there? There's 1, 2, 3, so that's trinomial. Cubic trinomial. Okay? So that would be the classification of it. So we're going to have some really easy questions like that on the Quiz Friday. Okay? The day after tomorrow. And we're also going to have some more challenging ones like this guy down here. This is a beast. Right? But you guys know Algebra 1, so you guys should be able to do this. What we're going to first do is understand how to read this. This does not say g times this binomial. It says g of this binomial, which means that we're going to take this binomial and plug it into the g of x function. Now over here they give you the g of x function, so we're going to take the binomial and put it inside the x and take the binomial and put it inside the x. So the first thing to do is to rewrite your g of x function, and that's going to be x squared plus 5x minus 6. So x squared plus 5x minus 6. And we're going to be actually plugging in the binomial c minus 1 inside the parentheses. So we're going to go c minus 1 right here and a c minus 1 right there. Okay? So let's actually work this out. In order to do the c minus 1 squared, you have to write it twice. So you're going to have c minus 1 times c minus 1, and you're going to have to do some distributive property. So c times c is c squared, c times negative 1 is negative 1c, negative 1 times c is negative 1c, negative 1 times negative 1 is positive 1. You could combine the middle terms. You'll have c squared minus 2c plus 1. And what do we have so far? We only have the binomial squared, but we still need the rest of this first part. So I'm going to distribute 5 times c, that's a positive 5c. 5 times negative 1, that's negative 5. And then bring down the minus 6. Okay? Now, what I want to do now is simply move everything down right next to this other quadratic trinomial and simplify it. So I have plus 5c minus 5 minus 6. All I did was take the 5c and move it down, the negative 5 and the negative 6. Now let's combine like terms. Our final answer on this left side is going to be c squared. And then let's combine the negative 2c with the plus 5c. That's plus 3c. And then let's combine the 1 with the minus 5 with the minus 6. That is a minus 10, correct? All right. So what we have so far is the answer right here to g of c minus 1. Cool? And now let's go back and do this part. So we're going to go back and do this other part, the 3 times g of 2c. So you might want to take this in parts. Let's do g of 2c first, and then we're going to multiply that answer by 3, and then at the very end we'll worry about subtracting. Okay? So let's plug in 2c into the g of x function. So there's a g of x function. Let me rewrite it. Parentheses squared instead of x squared plus 5 times parentheses minus 6. And we're plugging in 2c. So when you work this out, you have 2c squared, that's 2c times 2c, that's 4c squared, plus 10c minus 6. So this is just the g of 2c, but we still need to take that and multiply it by 3. So what I want to do is put parentheses or brackets around this whole thing and multiply it by 3, put times 3 out there in the front. And when I do that, I'll have a 12c squared plus 30c minus 18. And now what I have is this whole answer right here. But I still need to subtract, right? I need to subtract the blue answer and the red answer. So if I were to subtract, I want to put a big minus sign right here in the middle, between this guy right here, take away this guy, I'd have to distribute the minus sign to change all the signs. So on the first trinomial, I'm just going to rewrite it. C squared plus 3c minus 10. On the second one, when I distribute, I have a minus 12c squared, a minus 30c, and a plus 18 if I distribute over there also. So I have that giant polynomial. Let's combine like terms to make it nicer to get our final answer. When we combine c squared with the negative 12c squared, we get a negative 11c squared. And then we go for the c's. We have a positive 3c and a negative 30c. That's a negative 27c. And last but not least, when I combine the 10, the negative 10, with the positive 18, we'll get a plus 8 at the very end. You got it? Fun, huh? Fun stuff with the capital F. Okay. Moving on. So we are going to look at a second part of 5.3, and this is talking about end behavior. Okay, end behavior. So when you think of end behavior, you think about how it behaves at the end, right? So if I ask you, how does this graph right here behave as you go to the left? How does it behave as you go to the left? What's happening way over here on this graph? It's going down, right? And what's happening to this graph as you look at it to the right? It's going up. So in a nutshell, that's what we're going to be describing, but we're going to be using the correct notation with end behavior. Now, down here, it gives you the correct notation for the end behavior of the above cubic function. So right here where it says as x arrow negative infinity, that means as x approaches negative infinity. Okay, so you might want to do this. As x approaches negative infinity, what this really means is look going to the left. Okay? So as x approaches negative infinity, what that's really saying, well, you have your x values. Here are your x values. As you look at it from 0 to negative infinity, you're looking at it to the left. Okay, so as x approaches negative infinity, you guys just told me that the graph is going down, right? So as x approaches negative infinity, comma, f of x, which is also known as y, is also approaching negative infinity. So as you go to the left on x, you're going negative infinity on y. Does that make sense? Okay, so let's get comfortable with the phrase to the left or to the right. To the left is as x approaches negative infinity. To the right is as x approaches positive infinity. Okay? So if you look at the other one, it says, and as x approaches positive infinity, that means that you're looking at it towards the right. F of x, the y values approach positive infinity. Of course, if you're going this way, the graph keeps going up, 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 and up forever. So that's notation right there. Does that make sense? Yes. Okay, so let's just go over here to the side. Let me make a really weird looking graph. Okay, so let's state the end behavior right here. Okay, as x approaches, let's look at it to the left first. As x approaches negative infinity, what do we say about f of x? F of x what?
It also approaches negative.
Also approaches negative infinity. Because as you look at it to the left, it's going to be going down forever. And then also, as x approaches positive infinity, f of x, getting ugly, f of x approaches what? Positive infinity. Cool? Okay? How about that guy? As x approaches what? Negative infinity. I always like to look to the left first, right? What's happening? As x approaches negative infinity, f of x what?
Approaching positive.
There you go, approaches positive infinity. Put a plus sign in front. And as x approaches positive infinity, f of x approaches what? Also positive infinity. So notation's pretty easy, right? Cool. So let's go back over here. Now you guys are going to have to copy a couple of these down. I didn't get a chance to get the graphs on there, so you guys are going to have to copy them down. Up here it says if your polynomial function has an even degree, then the end behavior will be in the same direction. For example, y equals x squared, y equals x to the fourth, y equals x to the sixth. But they don't have to be that simple. It could be crazy like y equals 3x to the 6th minus 4x squared plus 7 or something like that. I don't know. But if your degree, your highest exponent is even, then the end behavior will both be in the same direction. Now we already know the most simple type of even degree function, which is a parabola. It's an even power, and we know that that's opening up. So end behavior is up here. All right? It doesn't matter what kind of exponent you have. If it's even, it's going to either open up or open down. Both of them are going to have the same end behavior, either up here or maybe down here, right? Power of 4, power of 6, power of 8, power of 28. It's going to have an end behavior in the same place. So at the end of it all, it's kind of like we're not even going to worry about what's happening on the inside of the graph. We just want to know that if it's an even degree function, it's either going to be opening up or down. So on this example and on this example, the a value is positive, and that's why it's opening up. But if you look at this example down here, it says likewise, if you have an even degree function and your a value is negative, if your a value is negative, then it's going to be opening down, but it's still the same thing. They're both, the end behavior is still in the same direction. Okay? So the end behavior is down here. So when your degree is even, they're going to be in the same direction, the end behavior. So you're going to be opening up here or down here, depending on if your a value is positive or if your a value is negative. So everything is explained in your notes. If you have an odd degree function, they're not going to be opening in the same direction. Notice this one opens up here in quadrant 1. This one opens down here in quadrant 3. Any odd degree function is still going to have end behavior up here in quadrant 1, end behavior down here in quadrant 3, right? Now, if your a value is negative, what happens is that it gets reflected on the x-axis. So you end up with this situation down here. I hope this kind of helps. We do have a homework assignment from the book, page 35 through 40 all, and also a worksheet that I'm going to hand out right now, 5 through 13 odd and 17 through 19 all.